So let's use some of these laws to manipulate Boolean expressions. So here we'll start with this one. And let's go ahead and start with De Morgan's law right there. Right, we have this complement of x times y. And so that one will work with De Morgan's law. Now I'm going to start using the single quote for the complement. Oops. So this one's going to stay the same, and I'm going to just apply De Morgan's law, which means now it is the complement of x, and then it changes to addition and the complement of y. So the complement of x plus the complement of y, and that's De Morgan's law. So I'll just type that right there. Okay. Now the next thing I want to do is let's go ahead and use this distributive. See how that we have the complement of x plus. And so if we look at that, we can take the complement of x plus out of each of those. So that's the distributive law. And that will then look like x, the complement of x plus, and then it will be y times the complement of y. And that is the distributive. Okay. And now we have y times the complement of y. So if we look down here at the complement laws, there's one that deals with that. And x times the complement of x. And notice that this applies no matter what variable is being used is equal to 0. So we end up with the complement of x plus 0. And that is the complement law. And then when we add 0 to anything, because of the identity laws, it's just itself. So we end up with x, the complement of x, and that is the identity law. Okay, and then we just do that leaves us with nothing left. We just have the complement of x as our final result. So notice how we simplified it a great deal, right? As we moved through there, we came up with that this is equivalent to the complement of x. And if you want to use that equivalency, you can, at each of these points, you can use the equal operator because we're really saying this is equivalent. And so it applies to put it there on each one of these. And in the end, we have this x, the complement of x.